Kyle, the time is 2:02, so let's go ahead and get started. Again, my name is Steve Runnels. I'm the Warning Coordination Meteorologist with the National Weather Service. And also joining us here as the main speaker for our presentation is Kyle Perez.
Yeah, thanks, Steve. I've done a couple of presentations as well with Steve here over the past couple of years. I've now officially been here for 3 years, so hope everybody is happy to join us this afternoon and gather some good information.
Absolutely, and to build off what Kyle said, Kyle kind of introduced this subject last summer when we had a summer hazards webinar, and that webinar is available via YouTube. But one of the things that we wanted to try to do is build off of that seminar and also bring it into the real world applications. We wanted to take a look at fairs, festivals, other events in which you have a large gathering of people. You're hearing from the National Weather Service that lightning or at least thunderstorms are in the forecast, and then build towards a position by which you can give us some feedback on what are you going to do with that information. Now, this is going to work for the emergency management community. John Elmore, if there's something going on at the hospital, other entities out there, we're wanting to kind of know what are your decision points. What information are you hearing from the Weather Service, and what more do we need to offer that allows you to make as good a decision as you possibly can? Okay. So with that said, again, we would like to try to encourage the use of GoToWebinar's tools. And with that said, Kyle, would you like to advance the next slide? Because I think you've got one built into your presentation.
Yep.
There you go. So using the question box, we can use it as both questions as well as for chat. We would love for everybody to be unmiked and be able to ask the questions in person. But let's use this tool as much as we can in order to make the most of it. And also, I'll give you a heads up that Kyle's got several surveys built into his presentation to also add to the engagement. So Kyle, with that said, take it away, please.
All right, thanks, Steve. So let's so we're going to dive right in here. Let's start with the science of lightning. So as mentioned with the title of this presentation, we'll be talking about kind of festivals and lightning and how this affects the decision support services side of it here at the National Weather Service, and also what goes into your guys' decision making when it comes to planning for events and when events are ongoing. So with the science of lightning, we're going to start here with this video. I can actually send this out. Steve, would you prefer me to send this out, or you want to play this over the camera or over the presentation here?
Well, tell you what, Kyle, I'm going to go ahead and put it in the chat, or put it out for everybody. That gives you guys an opportunity to watch the video yourself. It's a YouTube video. Many of you may have seen it because we did advertise it as part of the promotion for this webinar. But we would like you to take, it's going to be like 8-9 minutes, so it's going to be a little bit long, but I think it'll set the tone well for Kyle's presentation. So if I can go ahead and get you to go to that link and watch the video, and we'll come back about 2:15. Okay, for those of you that are watching the video, you should be getting close to the end. So we'll get started back up here in about a minute. If you came in just a little bit late, I did put the link to the video in the question or the chat box. So you'll have a chance to watch the video here a little bit later on at your time where it's available. So we'll get started here in just a minute. I would ask if you could, in the question box, please let us know what you found most interesting or insightful from the video. And we are taking a little bit of risk with this because obviously that video is pretty interesting, and your attention might be on the video as opposed to on the presentation. But as part of kind of an adult education tease, we thought we'd throw that out there and get started here in just a second. Austin, thank you for your comment about recognizing that lightning is the storm's way of regulating itself. I like the way you put that. Again, feel free to give us additional insights that you've picked up. And Kyle's going to highlight a few of the more important aspects here in just a second as well. Okay, Kyle, why don't you go ahead and take us forward.
All right, thanks, Steve. So hopefully everybody had a chance to watch that video. If not, Steve has a link, as he mentioned, in the chat section for you to follow up on later. But that video really goes in depth on how exactly lightning occurs and all the different strikes that occur. So let's dive in.
Hey, Kyle, we may have lost your audio.
Yep, can you hear me better now?
Yes, sir.
Okay. So I just wanted to share these two different videos here with you, kind of showing some different lightning strikes in slow motion. You can really see those streamers and step ladders moving through the sky, and then you can see the actual return strokes with the bright flash. What is exactly causing that? Well, with any kind of potential for lightning, we're going to need thunderstorm development. In this animation here, you can see how the thunderstorm develops. And then as that occurs, you begin to see the process of different charges. This was mentioned in the video as well. You get these negative charges kind of fall towards the bottom of the thunderstorm, while you have positive charges more towards the top of the thunderstorm. And then how exactly that process works, you have here on the right-hand side, you can see all these different little snowflakes, which represent ice crystals. And then you have those white dots kind of going across your screen there as well. And those are your grapple. So when those two collide within the actual cloud, that's where your charge separation begins to take place. And then as you can see on the left-hand side, kind of correlating those two together, within that collision process, you get the charge separation, which helps induce the eventual lightning process. So taking a look at this here, you can see the different lightning strokes that we concerned with. You have your intra-cloud flashes or strokes. Then you have your negative cloud to ground lightning flashes. And then your strongest ones, as mentioned in the video, which is often your most deadly ones, are your positive cloud to ground lightning strokes or flashes. Also, another process that I wanted to mention here to go along with the lightning process is your thunder as well. There's no really good animations to denote what exactly thunder is, but when lightning occurs, the thunder is actually the sound of the air expanding from the heat. And when that happens, it expands so rapidly that you hear the actual sound of thunder. So more or less, thunder serves as a warning sign that lightning is within the area, as you can often hear thunder sometimes before you actually see the lightning strikes. And that's because there's lightning strikes somewhere within your area, and that air is expanding and causing that sound that we know as thunder. So digging in a little deeper, what exactly are our concerns with lightning? I mean, outside of just knowing that it is deadly. Well, across the entire United States here, you can see that portions of southern plains into the Midwest region, and especially the coastal regions, those blue colors and dark purples, light blues, those areas there, which extend all the way into portions of Missouri, including southwest Missouri, which is generally in the dark purple to bluish colors, that denotes anywhere from 100 to 200 plus cloud to ground lightning strokes within a square mile per year. So as you can imagine, lightning strikes are not rare by any means, and can be a very, very big concern for any kind of events that are outdoors, especially during the spring and summertime when thunderstorms are going to be most common. As we mentioned, there is numerous fatalities each year across the United States and across the entire world with regard to lightning strikes. So focusing in here on my mouse, the second one there, just after flood, you can see that last year in 2020, there was 17 fatalities as a result of lightning. And currently the 10-year average is around 24, with the 30-year average as high as 39. So one good sign to go along with that is that you can see that with the 10-year being much less than the 30-year, and even the most recent year being less than the 10-year average, we've definitely hopefully made some progress here over the past 10 to 20, 30 years as far as lightning safety and knowledge, and sharing that information to make sure everyone's safe when thunderstorms are in the area. And taking a look at those lightning fatalities, how do those break down based off of different areas? So as you can see, that over 62% of lightning strikes fatalities are a result of leisure activities. And then those other 4 areas make up the other percentage of lightning fatalities, including 16% of your daily routine activities, 18% of those occur with work activities, and 4% are unknown. So since the leisure activity took up the largest portion of the actual lightning fatalities and counted for the most, I pulled the graph here on the right-hand side that looks at lightning fatalities, and this is based off of 257 cases from 2006 through 2019 with regards to leisure activities. And you can see that the large portion of that there is related to water-related activities. As we know, definitely probably have heard of the expression of to get out of the water, whether it's on the lake, in a pool. You definitely don't want to be in the water when lightning strikes. And as well as sports account for a large portion of that, and then kind of breaking down into smaller activities from there. So how does this all play together in concerns for being outside? Well, there's 5 different ways of concern for being struck by lightning. So this is the little animation I put together here. So your first way of actually being struck by lightning is going to be your direct strike. That's just your cloud to ground lightning strike connecting from the cloud to you, essentially. Your second way is going to be a side flash. So if you actually follow that stream there, you can see that it hits this tall object in the tree, and you actually get almost like a side flash that occurs where the lightning strike is able to strike you from that position. The third one here is a ground current. So this is where it would actually, it could even go through the tree into the ground or directly into the ground. But as you can see, as it hits the ground, it'll come back up through the ground and into a person there. So that's actually another reason why we definitely want you to be watching closely for lightning strikes, as it might not just necessarily go direct strike or an object next to you. Another common way that people are struck by lightning is through conduction. This is the main reason that we focus on making sure you are staying away from metal objects. You do not want to be holding on to something that conducts electricity, because as you can imagine, if this person here in this image was holding on to that metal fence, that would be a conductor of electricity, and that lightning strike would in fact then go through the fence into the person. And the last one here, this one was a little bit more tough to animate, but you have a streamer, which, as you can imagine, with mentioned in that video, there's a lot of like little streamers that are going on with a particular lightning strike. So in this particular scenario, you would have a lightning strike coming down through this tree and into the ground, but there's actually going to be streamers out, extending out through here that are not associated with the actual return stroke, but can still have a little bit of light up and charge with them as well. And that is how you'd be struck by a streamer. So now we'll kind of turn it over into Steve's portion of the talk here, and he's going to kind of dive into a bit more of what this means for decision support services.
Okay, thank you, Kyle. All right, so in the question box, I gave you another link to another short video. This one came from the Indiana State Fair, and it was really largely the genesis of the reason why the Weather Service started to promote decision support services. And of course, this is a strong or severe thunderstorm entering the fairgrounds, but you can see the impact as the grandstand starts to fall, the mass confusion. Unfortunately, there were injuries and even fatalities from this particular event. And I don't want to minimize the importance of severe thunderstorms, obviously, on a large fair or outdoor event, but it really does not take a severe thunderstorm to put your gathering in a hazardous situation. Obviously, lightning alone, being that it's the most prevalent thing from any thunderstorm, it's our focus for this particular concern. So Kyle, can you go to the next slide, please? So Kyle here has a poll question that he would like to ask you. And when you submit a DSS event request for an outdoor event, how high a priority is lightning in your planning and response? Give me a couple minutes to answer this question. Okay, I see that we're up to 80% voted. So just got a couple more of y'all, if you could go ahead and answer that question. And I can say overwhelmingly that those that said high are in the majority. So let's see, with 80% of the vote in, I see 94% high, 6% medium, and nobody said low. Good, good. And again, that is the main threat from any thunderstorm. Obviously, all thunderstorms are going to have lightning. The question that as we get further into this conversation, the question then becomes, so what are you going to do about it? Especially if your fair or festival is in the middle of summer where we do get a lot of short-lived thunderstorms. it's not like a spring storm where you have a line of thunderstorms come through and that's the end of it. You might during the summer, on a typical summer afternoon, have multiple rounds of thunderstorms followed by sunny skies in between. Next slide, please. So I'm really looking forward to your thoughts on how you apply the services that we provide when it comes to lightning notifications. We're going to take a look at hours before the event. We're going to take a look at either a distance or a time factor before it starts moving into your event. And maybe even some of the factors that we need to consider when we start asking you guys for lead time, 30 minutes, 60 minutes, maybe even longer, in order to get information out to the public. I want you to consider, as part of this section, think of ball games, think of mass gatherings, think of smaller events in which maybe there's some pop-up style tents that people are gathering under, waiting for the rain to end, not necessarily being all that concerned about lightning. And I also want you to think about events, incident command, or events in which maybe there's a police officer out or fire dispatch event, maybe a missing kid, so events that vary in nature, but all are potentially affected by lightning. Next slide, please. So when you consider that majority of people do move indoors when it starts to rain, one of the considerations that we have for y'all is, when is the lightning risk the greatest? And this graphic helps to show you that by the casualties. It is actually a greater threat as the thunderstorm approaches, where the thunderstorm starts to depart. So that kind of that purpley pink line, whereas the yellow orangish line suggests that when it is raining, when the thunderstorm is overhead, it's actually the lowest casualty time associated with that thunderstorm. So it's kind of inverse in expectations. And this is part education. I hate to say it, this is part human nature. Again, we're smart enough to come out of the rain, but not necessarily smart enough to come out of the lightning. So as you build your event planning documents, recognize the fact that people will tend to only respond when the rainfall arrives and the risk is actually before the storm approaches or after it departs. Next slide, please. So I have some considerations for you. Let's consider a special event in which you did not request DSS. In your question box, I'm going to invite you to fill out the blank in that first bullet. When thunder roars, go. What do you think happens at special events? What do people do? Give you a second to answer that question. Karen McGinnis, you say indoors. Tom Williams, you said inside. Stephen McLean, look at their phone. I think that's a great answer. Honestly, that's probably my answer. I was out on the golf course last Saturday, and I was watching radar coming in. Lori Sneed, go to the many booths as possible before the rain starts. So you're looking at it from an organizer point of view. Thank you, Lori. What other responses? What do you think the mass public does at special events? Probably the same thing they do at home. They try to determine what is their level of threat and grudgingly maybe take shelter. Of course, when thunder roars, go indoors is the slogan that we try to share, but literally we recognize that the response is varied. Sometimes people actually still take shelter underneath trees. Some people will try to take shelter in garages, maybe into cars. So these are some of the things that we'd like you to consider for your special events. Now, the 30-30 rule is something that the Weather Service did advertise for a couple decades, but we really have gotten away from that as lightning science increased and our ability to communicate through DSS increased. The first 30 in that 30-30 second rule considers the difference between the speed of light and the speed of sound. And if you see lightning, you can start counting, and for every 5 seconds, that lightning bolt was a certain number of miles away. So 5, 10, 15, 20, mile, 2 miles, 3 miles, 4 miles. The challenge that we have with that is that you do not know where the next bolt of lightning is going to come from that thunderstorm. So while you're counting a storm or a lightning bolt that's maybe 3 or 4 miles away, the next one might come from the front of the storm and surprise you. The second part of that 30-30 rule, wait 30 minutes. Now, this is much better advice. So the line of thunderstorms has come through, like it did to me on the golf course last Saturday, and the storms are obviously off to the east. If you look at radar, the red blob is maybe even a county or two over. Then all of a sudden you get a bolt of lightning, or at least you hear thunder. Kyle's going to cover long strokes here in just a second. But we've got to recognize that the 30-30 rule has serious limitations. Now, the other thing, if you do not have DSS, yeah, if you have a lightning detection system in one of these handheld or maybe even computer systems, there is value there. And yet, that value is largely tied to where lightning has already occurred, not necessarily where the next strike is going to occur. So please consider that all these things, without support from the Weather Service, simply gives you an idea of where thunder has been, where lightning has been, not necessarily where it's going to occur next. Now, from our aspect, we certainly have got some additional tools available to us at the Weather Service, including monitoring lightning from satellites, as well as looking at radar and utilizing some meteorological principles on where lightning is going to be possible, but we still have to message it to you. We still got to give you a feel for what is the likelihood and where is the next threat area going to exist. So it's something that we're still expanding in capability, but nonetheless, I think it's something that has already proven to be successful. And Kyle, would you like to go to the next slide, please? Now, when you're planning your DSS event, you put your report, your request in, I give you a phone call back, and we start talking about how long is it going to take to get the public to safety. There's a little bit of time for us to recognize the hazard and for us to give you, as the point of contact, a call. Then you typically will use some sort of a communication channel to mass notify both your people and then ultimately the public. And the last time that is pretty important is how long then does it take the public to get to safety? How long does it take to get people from the football or baseball game to their cars or indoors into a building? How long does it take to get information across the fair or the festival? And you know what? How long does it take to convince people to go to places of safety? So please think about your notification channels, both back and forth to the Weather Service as well as back and forth to your people out and about, and then lastly to the general public. Think about the shelter options. Are you going to get people indoors, or are you going to get people to their cars? And do we incorporate that time factor in getting them to safety? Often we get requests for a certain distance of where that lightning threat is compared to the fair or the festival grounds. I really like to go with time rather than distance. That way the meteorologist can factor in how fast the storm is going, because the storm moving at 60 mile an hour versus 10 mile an hour has quite a bit of varied response in terms of lead time to your event. So I recognize the desire for distance. It's easy to plan for. It's easy to put into a plan. And I'm going to give a case example here in a second. But the bottom line is time is so much more critical than distance, especially when you consider that thunderstorm is maybe 15 or 20 miles in diameter. Additional factors I'd like you to consider is this, and I'm looking forward to your responses when we get to that section. Let's consider isolated strikes, typically seen during thunderstorms in the summer, versus organized thunderstorms, supercells, squall lines, something that has a regular movement to it, and you can plot its arrival time into your fairgrounds. Now, we often consider movement off of what radar has presented to us, but meteorologists will be considering propagation. Where are thunderstorms developing? Maybe in a different direction than the movement, or maybe well out ahead of where thunderstorms are currently at as part of that propagation of the storm system. And then lastly, Kyle, we're going to turn over to you, and we're going to talk about long strokes. So that's that event where the thunderstorm is a county or two away, and yet you get a lightning strike out of the blue. Kyle?
Yeah, Steve, thank you. So, kind of going back to that graphic that Steve referenced just a few slides ago, he mentioned that not only is the threat for lightning still there as the thunderstorm's approaching and as the thunderstorm is overhead, but there's still a very great lightning potential after the storm has actually departed. So how exactly does it occur? This graphic here is going to kind of depict just a brief idea of what allows that to happen. How do you get lightning strikes so far away from the actual parent thunderstorms? So with this particular graphic here, this is kind of similar to what was just shown earlier on in the presentation, where you get your charge separations between ice crystals and grapple occurring within the actual main updraft of the thunderstorm. You get your negative charges here across the lower part of the thunderstorm, and your positive charges are pushed much further towards the top of the thunderstorm. But with a larger complex of thunderstorms, you essentially are able to get that charges and ice crystals pushed all the way back into the stratiform region of the thunderstorms. So the lighter, moderate rain typically that you see after a large squall line or complex moves through the area, you see that rainfall behind that kind of just lingers. And you think, well, maybe now that the main stuff has passed, maybe we're in the clear now. And that is not true. There is still going to be that lightning potential after the main parent thunderstorms have moved through. So I have a particular example here. These different letters here and the yellow dots denote 4 different events for this particular example that would be ongoing. You have event D that's just out in front of this storm complex as it moves towards the east-southeast. You have event C down towards the bottom part of the screen, and this particular event is seeing the brunt of the thunderstorm right now and is overhead. And then you have event B, which is just past or just saw the thunderstorms move through their area and is kind of seeing some light to moderate rainfall. And then you have event A up here that had thunderstorms pass through maybe, half hour, 45 minutes ago, but still seeing some lighter, moderate rainfall. So given that there is the potential for those long strokes to occur, as mentioned with the graphic on the last slide, that brings up the question for here. I'll go ahead and launch this poll here as well. Which particular events have the potential to be impacted by lightning on this given graphic? So I'll go back to the graphic 2. Would it be C and D? I'll remind you, C and D were the 2 that were right along and ahead of the thunderstorm complex. B, C, and D, so that would include the 2 that are right along the complex and the one that just had the thunderstorms go through. Or is it just A and B, which are the ones that already had thunderstorms move through half hour, 40 minutes ago? Or are all of these events in the threat for lightning? Go and wait a minute here or so for some answers, more answers to come in. It's looking like the overwhelming majority so far at 100% is with all the events. Let's go ahead and close that poll here. So it looks like the overwhelming majority did pick the correct answer. All events would have the potential of seeing lightning. How are we able to detect that at the National Weather Service when providing decision support services for those events? This is actually one of the newer ways that we are able to assess that. I overlaid this product that we use at the National Weather Service over the actual radar that I had just shown you on the previous slide. And you can see all these different pixelated blue colors, yellows and oranges kind of pixelated over it. So what this actual product is showing us is the potential, the flash extent density. And when we, as the National Weather Service, are able to see this on our satellite products, we're able to denote that this area here, all through this blue and the light to moderate rain, this is where long flashes are likely to occur within the next couple of minutes. And clicking forward one more time here, you can actually see that those white circles denote where the actual events were, A, B, C, and D. And you can see that they all have lightning potential, especially even back into this stratiform rain region well after the main thunderstorm line is passed. So even though the appearance may be that the heavier stuff and the main winds and gusts have come through, maybe some hail, and you kind of just fall back into this light to moderate rainfall, the threat for lightning strikes still exists well back beyond into this area. And that's what we are focused on with long stroke potential. And these can be anywhere from 50 to 75, even 100 miles back behind the actual main parent thunderstorms. These lightning strikes can actually travel. So that brings us to our third and last poll question here. And that question is, when submitting a DSS event request form, what is your typical request with regards to lightning concerns? And Steve touched on this just a bit earlier on. Are you focused more on A, the time of arrival, 30, 60 minutes? Are you focused more on B, which is the distance of lightning strikes away? So do you want to know that you want to know when the lightning is, 5 miles away, 10 miles away? Or are you more focused on if there's any lightning strikes within a certain radius of the event, whether that's in front of the storm, behind the storm, north of the storm, any kind of lightning strikes within the radius? Or is your answer D, other? If you choose other, go ahead and put that in the question section on what you would be most interested in for that. I'll go ahead and launch that poll here. You should now see that poll available for you to answer. And while we're kind of waiting for these answers to come in, Steve made a really good point on that most recent example that we just kind of walked through with the events at A, B, C, and D. And he asked how much pressure for emergency management officials, anybody that's leading the particular events, whether it's fire, how much pressure would be on you as the leader of that event to restart operations at those two locations that were beyond the actual parent thunderstorm? So that would have been events A and B that were just kind of seeing light to moderate pockets of rainfall moving through the area after the thunderstorms moved through. So we kind of want to just kind of keep that question in mind We'll have a time for discussion here coming up, but that'll be a good question to come back on. So go ahead and close the poll here. It looks like it's kind of split decisions here. We had 56% of the people are interested in C, if any of the lightning strikes occur within a certain radius of an event. 38% were focused on the time of arrival, whether that's 30, 60 minutes away. And then 6% answered other. Steve, do you have any of those to share with us from the comment section there?
One of the responses to the other was all of the above. So they're taking both the time of arrival as well as how far away from the event into account in with their concerns.
Okay.
And I think that's a good answer. At least it's a very pragmatic answer. You know, much like the public who's looking at their phone, listening for thunder, trying to figure out what's going on. If you do have a distance criterion and you are considering time of arrival, it makes sense. I do understand that. Typically speaking, again, time of arrival is where the state of the science is becoming. We're not quite to the radius of the event. We would love to be able to give you that, but I don't think from a services standpoint, we can consistently provide that information.
All right, thanks, Steve. So kind of moving on here, I'll let Steve take this one over here. This is going to be another kind of example of what we are looking at from our side of supporting different events across the region or across our area. So if you want to go ahead and take that over, Steve.
Absolutely. Okay. I want you guys to put yourself in one or more of these considered events. They're lettered A through H. The bigger circles indicate a greater distance. Think about it as 30 minutes, maybe even 60 minutes away. That is your zone of concern. The smaller circles are maybe 5 miles in diameter. So very, very small zone of concern. I want you to think about at what point would you cease operations? Now, again, it might be a hazmat event in which you've got people on the roads. It might be a fair or festival. It might be a football game. So consider the smaller circles versus the bigger circles, whether it be time or whether it be distance. And as we start to consider requesting DSS services, I want you to kind of play those things through your mind, recognizing that the longer the lead time, maybe the less accuracy that the Weather Service will have. The smaller the circle, especially when you start getting down to those 5 mile in diameter requests, what is our ability to actually say that part of the thunderstorm versus another part of that thunderstorm, the risk is going to exist. Next slide, please. So with those circles in mind, let's add some radar. Does this change your thought process? Look at that point up there at the top of the screen, point G. Thunderstorms are off to the west. Let's consider a movement to the east, and we can really time it into your location. Let's go to point F, down there to the southeast. Thunderstorms there are actually moving away from your event, but maybe it's still cloudy. Maybe you're hearing rumbles, but you look at radar and that storm's going away from you. Same thing maybe in point D. Now there's one under, let's use one of the small ones. Kyle's at point B, I believe. Okay, this is what I faced back in the spring when the Missouri National Guard provided us with a 5 mile diameter in which we were to alert them with the approach of the thunderstorm or 5 miles away from the storm as it departed off to the east. And it frankly made me very uncomfortable. I did it, I agreed to do it, at least I should say, largely only because I knew thunderstorms weren't going to be around that particular day. So as we start to build our plans, I want you to consider distance versus time. I want you to consider how long it takes to get information out to the participants, but more important, I want to be able to consider the messaging component. How do we get information to you such that you believe it, you understand it, and you respond it, and then the people that you serve do the same. Now, as you request DSS in events, and we draw these circles on our main communication system, our forecast and warning system, overlaying your circle on radar, or the next slide, on satellite, these are all tools that we've got available to us that, in my opinion, really give you a heads up than just keeping an eye or an ear to the sky, maybe using a lightning detection system. Satellite gives us an excellent opportunity to know what's developing, not only what's out there like radar tells us, but satellite also gives us the ability to know what's developing. Next slide. And then lightning actually does start to develop. Now, going back to your consideration for the different events, you'll see pluses and minuses on your screen, but you also will see hash marks. The pluses and minuses are actual cloud to ground strokes. Those are positive strokes, those are negative strokes, but they're CGs, cloud to ground strokes. The flashes are in cloud. Now let's go back to considering some of those points that we talked about, point G, point F, point B, and where are services well done and where do we need to improve. Let's go to that National Guard site, that 5-mile diameter site. There's no lightning whatsoever associated with that band of heavy rain moving in. Point G, there's a lot of in-cloud flashes, maybe not a whole lot of cloud-to-ground flashes. Is that a situation where you're going to be able to go to your commissioner and say, I'm going to shut down the fair that's bringing in quite a bit of revenue as thunderstorms are coming in? Or point F, remember, that's the one where the thunderstorms are moving outside of the circle, and yet you're seeing some flashes and maybe hearing the rumbles of thunder as those long strokes are occurring. So these are just some things that Kyle and I and the rest of the meteorologists at the National Weather Service do observe from time to time. But then there's other events, and we didn't really talk about this up to this point in time. Look at the little yellow circles off to the west and off to the east. These are events in which we did not get any DSS requests. I hope there's somebody there's a safety officer at those events that are keeping an ear out. Maybe they're watching radar. Maybe they're even communicating back to the National Weather Service via NWS chat. But these are events that we do not know about. Now, I'm going to draw your attention to one more point. That's the one that's north of point E, up at the top of your screen. This is an event that they did not ask for DSS. And you see the thunder, or at least the in cloud, maybe there's a couple of cloud to ground strokes. Maybe it's an event that you canceled early, but I'm hoping that that's not an event that you're waiting to see if there's a threat before you notify the Weather Service. Because if you have not asked for DSS before this point in time, we do not have the ability to put these circles on our communication system, on our forecast system. So we're really kind of operating in the blind as far as where your event is, what are the parameters that you're concerned about. So we need to do a better job with that event organizer. Next slide, please. So these are the area that I would really like some feedback. I'd like you to answer or ask at least or post some questions in the chat box, in your question box, as far as it relates to why do we want to request DSS. And from our side, it provides an excellent opportunity for pre-event collaboration. We get to know who the point of contact is. What is the phone number? Where is even the location of the event? There's been several events that we can't even find them on a map. But by providing latitude and longitude, we know exactly where. That pre-event collaboration, we also get a chance to ask, all right, what are your time frames? 30 minutes, 60 minutes? If it's not lightning, maybe it's wind, 30 mile per hour, 40 mile per hour. Maybe it's rainfall and flooding. An inch of rain in 30 minutes is going to cut off a low water crossing. So these are important considerations that we can collaborate well before the event. Now, in order for us to help you, we need to know in advance. So we need that DSS request to come in well before the morning of the event. And this is one of the things we noticed on the 4th of July weekend. We got a ton of DSS, either over the phone or via NWS chat. That makes it very difficult for us. So if you request DSS in advance, we can augment staff, we can get that event placed on our workstations, and we know exactly where the storm is and how far out before we give you the call. Next slide. Now, there are a couple different considerations when it comes to time frames. The first thing, yes, you can request a pre-storm briefing. Sometimes that's only if weather is going to make have impact. We'll be glad to provide it either way, but I recognize that sometimes you don't want to call at 8 a.m. Just telling you the weather's going to be great. On the other hand, you'll often get phone calls from our guys a couple hours before the event. I recognize both your desire for that information, but also I recognize our desire to give you the call and say, hey, we got thunderstorms starting to pop up near Joplin. It's probably going to be 2 hours before it gets to your venue, but it's out there, and the lightning potential is starting to go up. On the other hand, now that site-specific notification is provided when it's 0 hour. It's happening. It's coming in. Our confidence is high. That lightning is going to arrive. So my discussion questions, and I'm going to invite you to pick any one of those to give us your feedback. What do you do with that information? Think about the pre-storm briefs, the awareness calls, the site-specific notifications. What do you do with that information? Same thing for what is the response by those that you forward the information to. Now, it might be an event organizer, it might be the general public, it might be the on-scene incident commander, but what is the response? What do they do with it? Do they immediately call off operations or cease the fair, or do they ask you for additional information? Then the last discussion question I have for you is, what do you need from us to enhance response? I'm gonna give you a couple minutes to think about those answers, and go ahead and just put them in your question box for us to give you some responses to. So again, please pick out one of those questions and give me your answer. Give you a couple minutes to think about and type up your response. Please be sure to give me a little bit of background if necessary. Think about that county fair. Think about that high school football game. Think about that missing kid search. Any kind of outdoor gathering. And then go to your question box, your question GUI, and give us a feel for what situation do you find yourself in. What information would you like from the National Weather Service? What would you like the people that you serve to do with that information, or to get the desired response? I see a response for Stephen McLean. As far as enhanced response, the ability to send documentation along with the phone call so that the decision makers can get all the information to make decisions. Very interesting. Kyle, I don't think we've ever had that type of request come in, but I think that makes sense. What other situations do you guys find yourself in? I see Patty Palmer, outdoor amateur radio events such as field day, site-specific notifications to move people indoors, detach sensitive equipment, and make other event decisions for safety purposes. Patty, maybe as a bit of a comeback to yours, at what point in time do the hams decide to take those actions? We'll come back to that. Jacob Marler, I use the information to prepare for canceling events and or moving people to safe locations. Jacob, I know you've requested several DSS events. I don't know if any of them have involved lightning, but ultimately, do you find yourself successful or making those decisions that you remarked upon, whether it be canceling in advance or moving people to shelter? Do you find yourself successful based upon the information that we share? And I'm okay with y'all maybe making a collective, but there's probably a couple events in your experience that maybe stand out. Is there anything that we need to do, much like what Stefan had suggested, providing a combination of graphics and information? Is there anything else that we need to do a little bit better, a little bit differently? Lewis, we should have called for a briefing before field day, rather than just relying upon hearing thunder and going indoors. Patty, I see you usually make the decisions 30 to 60 minutes in advance, so you're trusting that forecast. But you're also on site. You're paying attention to what's going on locally. Okay. Well, guys, we've hopefully planted some seeds in as far as the lightning science, a better understanding. It's not just cloud to ground. It's not unheard of for lightning to touch down 10, 20, 30, 40 miles away from where that red blob is on radar. You know, hopefully we've given you some considerations on the importance of requesting DSS in advance, as it allows the setup at the National Weather Service. It allows us to know what your parameters are. It allows us to know who the point of contact is and the lead time before we have to notify of lightning. We touched a little bit upon the tools, NWS chat, the event support request form itself. If there's something else that we need to take a look at and do a better job with, please don't hesitate to give us some feedback as we go forward. So Kyle, if we'd like to go ahead and go on. So some final takeaways. One of the considerations that we will have for you is we want to share safety graphics. We want to utilize and leverage social media. You know, if there's something that we post, these are good opportunities for you guys to steal, to comment, to forward, to like, but they're also available on the National Weather Service page for you to grab and localize for your own purposes. And then some final takeaways. It's not necessarily a time of arrival, but distance. We're smart enough to know to come in out of the rain, but not necessarily before the storm arrives or after it leaves. We need to continue to promote weather safety. I think we've all lived through thunderstorms. We recognize that the chances are pretty low that we're going to be struck, and then all of a sudden you have a tragedy. So we've got to continue to work together to consistently promote the same messages. And then I really hope the final takeaway is the value of requesting DSS event support. It really is easy for us to monitor and then notify you, but that is only if we know where your event is and your individual needs for that event. So please, please, please submit your requests. On top of that, we've got some means to communicate with the Weather Service. If you have an NWS chat account, that is just a fantastic way. Otherwise, you can see on this slide some additional means by which to communicate with us as well. Kyle, I don't know, do we have any additional comments come in?
Nothing here yet.
Okay. Guys, that's all the material that we've got for y'all. We'll stay online here a couple minutes in case there's any additional questions that come in. But with that said, I thank you for everybody's attendance here today.